Bismillahirrahmanirrahim. So today's lecture is about the shape of the orbitals. अभी तक क्वांटम केमिस्ट्री में हमने वेव फंक्शन के बारे में पढ़ा है. Then the concept of the orbitals also we have understood. Now how we can actually see the orbital, whether it is spherical, whether it has some a dumbbell shape or whatever type of shape it has. So now how actually we say that it has this type of a shape. तो क्या चीजें जरूरी है एक ऑर्बिटल को एक पर्टिकुलर शेप देने के लिए या एक शेप एक्वायर करने के लिए. Now shape of the orbitals में हमारे पास जो सिलेबस है, that is it says the shape of S orbital, P orbital and D orbital. तो ये आपके सिलेबस में जो शेप्स है, that you discuss the shape of S, P and D. Now first of all let's take the example of S orbital. तो शेप को डिस्कस करने के लिए हमने पिछले लेक्चर में पढ़े थे क्वांटम नंबर्स. हमने कहा था क्वांटम नंबर्स आर सेट ऑफ वैल्यूज which are used to designate an electron or electronic wave in an atom. तो S orbital के लिए let us see, इसमें दो क्वांटम नंबर्स बहुत अहम है, दो which can actually give you the idea about the shape. One is L and M, that is azimuthal quantum number and magnetic quantum number, or it is also called as angular momentum quantum number. So this is also called as angular momentum quantum number, angular momentum quantum number. It's also called as azimuthal quantum number, and this is called as a magnetic quantum number. Azimuthal quantum number gives us idea about the number of subshells in a given energy level, or number of sub-energy levels in a given energy level. And magnetic quantum number gives us the concept of the orbital, that is it gives us the possible number of orientations. ये हमने पढ़ा था. So how many orientations an electronic cloud, electronic wave can occur around the nucleus? Those number of orientations is given by the magnetic quantum number. ठीक. Now S orbital के लिए L value, हमने ये टेबल दोबारा हम बना लेते हैं. हमने कहा था S, P, T and F. So your L value is 0, 1, 2 and 3. This is the L value, this is the orbital, and this is your L value. So this is your name of the subshell, and this is the L value. So for S, L value is 0. L value 0 means it has a single value. So for S orbital, we should say that this L has a single value, that is 0. And now if we talk about the M के लिए हमने फॉर्मूला बोली थी minus L through 0 to plus L. Now L is 0 for S, so minus 0 through 0 to plus 0, 0 means that is all 0. So that means its M value is also 0. That means when the L value is 0, M is 0. M 0 means it has a single orientation around the nucleus. Single orientation, we know अगर orientation single हो, that means the shape is spherical. So spherically symmetrical orbital has a single orientation. That means ये जो S orbital है, that is basically spherically symmetrical. It is spherically symmetrical. Spherically symmetrical. Symmetrical. Now, so turns out that S is spherically symmetrical because M value is 1. It has a single M value, that is 0. So it has single orientation in the space. Now, how many nodes and how many nodal planes are there? Then only we can finally judge the shape. Number of nodes is given by, if you remember this, that was N minus L minus 1. Now for S orbital, N is, we have to see which N value that was having. Let us say it is 1s. So then N is 1. L is 0 and this is 1. That number of nodes is, that is no node. That means if you have 1s orbital, then it has no node. If it is 2s orbital, then this becomes 2, so 2 minus 1, so that means it has 1 node. If it is 3s orbital, that means it has 2 nodes. And nodes are the those the regions around the nucleus where the probability of finding electron is 0. So these are spherical nodes. So अगर हम इसको draw करें तो we can draw it like this. So this is your 1s orbital. This is nucleus, and then we have electron density around the nucleus, spherically symmetrical, and there is no node. So this is your s orbital, shape of this orbital. Now if it is 1s orbital, if it is 2s, so 2s के case में we have 1 node. So 1 node is like this. That means so this I'm showing electron density. Now you can see here your space in the region. If you move from the nucleus, electron reach here, and then this space, it is no electron. That's called node. And then again the electron density. So this is the shape of the 2s orbital where it is 1 node. This is the node. Likely when we talk about the 3s orbital, it has 2 nodes. So then you have to move away further. And then again create a space here. And then this is electron rich. So now you can clearly see here, this is nucleus, electron density 1 node, then again electron density, then 2 nodes. So this is, and then again electron density. So this is the shape, spherical shape of 1s, this is 2s and then 3s. मैंने तीनों के एक ही में दिखाया. So this is s orbital. Now let us talk about the p orbital. So p orbital. Now this is your p orbital. Now what is the value of L for p orbital? For p orbital the value of L is 1. What is the value of M? Minus L through 0 to plus L. Now minus L through 0 to plus L ऐसे निकाल सकते हैं हम. Minus 1 through 0 to plus 1. So that is minus 1, 0 and plus 1. So इसका मतलब है 3 orientations. So N has 3 orientations. That means its electron density is orientated around the 3 axis. 3 orientations means P has 3 orientations. So that means it has 3 orbitals basically. So those orientations, that means one orientation can be along the x-axis. If we say this is x-axis, the shape is like this. And then if we talk about the y-axis, shape is around this. And then if we talk about the z-axis, let us say this is the z-axis. So the shape is like this. Now why actually am I making the shape like this? ये question है. देखिए ये जब हम वेव फंक्शन को सॉल्व करते हैं श्रोडिंगर वेव इक्वेशन में, देन उसकी जो वैल्यूज निकलते हैं वहां पे, देन वी प्लॉट दिस देम मैथमेटिकली. तो मैथमेटिकली हम प्लॉट करने से वी एक्चुअली गेटिंग दिस टाइप ऑफ शेप. अब दैट इज नॉट द स्कोप हियर. जब हम हायर लेवल पे जाएंगे, इवन एडवांस्ड लेवल पे आफ्टर पीजी, देन वी कैन एक्चुअली ट्राई टू ड्रॉ दिस विद हेल्प ऑफ द सॉफ्टवेयर्स. सो इट्स एक्चुअली these are basically the graphical representations. It's a mathematical procedure. So this is the shape of the p orbital, but it's oriented along this orientation is given by this M3 orientation, means oriented along the x, oriented along the y, and electron density oriented along the z. So it is 3 orbitals, and the shape is like this. It's called as a dumbbell shape. So this is called as the dumbbell shape of the p orbital. So it's called as a pz. This orbital is called as a py, and this is called as a px orbital. So these are the 3 orbitals, px, py and pz. And then अगर आप देखोगे, then one more concept is that we sometimes give plus sign to this orbital and minus sign to this. Likely plus sign, minus sign, then plus sign, and minus sign. Whereas in case of S orbital, we will only give plus sign, or we don't give the sign. Means ये जो signs है, why it has a plus sign and a minus sign, whereas S orbital is not having. देखिए, S orbital में, if you remember this, the shape of this orbital, it depends only on the radial function. Radial function. That is this part, radial part. And we know that it depends on the quantum numbers n and l. It can be solved with the help of constants, which is principal quantum number, azimuthal quantum number. While as P, now P, this wave function depends on both radial part as well as the angular part, that is theta and phi. And this depends on n and l, and these wave functions depend on L and then M also. And M is basically the use of the concept of the orientation. So that since P orbital and as well as the D orbital, both these orbitals, their wave function is a construction of angular as well as radial. Angular wave function has, because of the angular wave function, they are getting this sign, this plus, plus and plus. So that was the concept of the P orbital. Now P orbital और एक चीज है, ये जो region है यहाँ पे, this one, this is called as the nodal plane. Now let us calculate the number of nodes and number of nodes in P orbital. If it is 2p orbital, the number of nodes is given by n minus l minus 1. That is 2 minus, per p value l is 1. That is no node. If it is 3p, if it is 3p orbital, that is 3 minus 1, that is 1 node. 1 node. Now how can we show that node? ये हमने किया था, लेकिन again I will show. Let us say it is a px orbital. Now you can see the space here, this one, this space. This is a node, this space. So this is how the nodes we can show actually. So this is the node. So that means 3p orbital has 1 node. Fine. And then when we talk about the nodal planes, see, 2p orbital, the number of nodal planes is given by L value. So there is no nodal plane. Sorry, in case of 2p orbital, L value is 1. So the nodal plane is wire. So the nodal plane is this one, which is actually passing through the axis. This is basically a plane. It is a nodal plane. Likely in this case, a nodal plane which is perpendicular to the y-axis. A nodal plane which is perpendicular to the x-axis. So this is the nodal plane. So in case of p orbital, we have 1 nodal plane or 1 angular node. So in this case also, this is the nodal plane which is passing through this. So in case of 3p orbital, there is 1 nodal plane and 1 node, or 1 spherical node or 1 angular node. Now let's talk about the third one, that is the D orbital now. The shape of the D orbital. So for D orbital, L value is 2 and M value is, that we can easily calculate, minus L through 0 to plus L. So minus L is minus 2 through 0 to plus 2. That is minus 2, minus 1, 0, plus 1 and plus 2. That is 1, 2, 3, that's 5 orbitals. That means its M value has 5. So it has 5 orientations around the nucleus or space. So that has 5 orbitals. So that means, and those 5 orbitals have been designated as dxy, dyz, dzx, then dx square minus y square, and dz square. So these are the 5 orbitals which are present in the D subshell. So these are 5 D orbitals. The dxy, dyz and dzx, it means that its electron density is oriented between x and y. That is its lobes. इसके जो lobes are, they are oriented between x and y axis. dyz means its electron density or its lobes are actually located between, they lie between the y and z axis. And in this case, they lie between z, this is z and x axis. While in dx square, y square means its lobes are perfectly oriented along x and y only. और dz square which lobes are oriented along the z axis. Now अगर आप देखेंगे तो ये जो set of orbitals है, here the electron density of these orbitals is located in between the axis. So this is in between the axis, electron density. And this case, the electron density is located along the axis. Along the axis. That is why this set of orbitals, this is called as a T2G set also. So the name of this orbital is T2G set. In basically हम name देते हैं in the advanced studies, symmetry and group theory, but that I will not discuss here. And then this set, that is dx square minus y square, जिसमें electron density is along the axis, it's called as a EG set. Okay. Now let's talk about their shapes. That is dxy. So electron density is located in between the axes. That means if we take it dxy, if we say it is x-axis, this is y-axis. So your electron density is located between this. This is your plus sign, this is minus sign. And then this is your minus sign, and this is your minus sign. So this is your dxy orbital. Now it's a dxy orbital, and then number of nodes you have to calculate at the same time. So number of nodes is given by formula. What's that formula? N minus L minus 1. Let us say it is a 3D orbital. 3D orbitals का ले लेते हैं. N minus L minus 1. 3 minus L for D value is 2 minus 1. That is 0. So the number of nodes is 0 in this case. What is the number of nodal planes or angular nodes? Nodal planes or angular nodes. Number of nodal planes or angular nodes is given by L value. L value for D is 2. So there are 2 nodal planes, and this is the one nodal plane is there along the x-axis passing through the nucleus. Another nodal plane which is perpendicular to this passing through the y-axis. So there are 2 nodal planes, this one and this one. So the number of nodal planes or angular nodes are 2, and this is the dxy orbital. Same is the case, you can draw dyz. आपको axis रखनी है y और z axis. So you can take it y, keep it z, and then you keep the electron density here. And then the signs, plus sign, minus sign. So this is your dyz orbital. Electron density is located between y and z, and then it has, as usual, 2 nodal planes and no node. And then we can also accordingly write dzx, where you can draw the axis. This is your keep it z, or keep it x, keep it z. So this is your plus sign, minus sign. This is the same dz axis, and then the orbital is dzx, where the lobes are located, or electron density is located between x and z axis. And then these are the nodal planes, one nodal plane here and one nodal plane here, perpendicular to each other. So these are the nodal planes. Now अब इसमें 2 important orbitals है, that is dx square minus y square and dz square. Let's move to those dx square minus y square and dz square orbitals. So dx square minus y square. अब देखिए x square, it means wave function का square, and then y square. So इसमें electron density is located along the x and y axis. You can make it like this. So if you keep it y and keep it x, so electron density is located perfectly around. It's oriented along x and y axis. These are the lobes. Okay? So you can keep this plus sign. So the lobes are located along the x and y axis. That's why it's called as dx square, and this is dy square. So this is dx square minus dy square, and then it has no node, but there are two nodal planes here which are perpendicular to each other. This is one nodal plane, this is another nodal plane, this is the nodal plane. Now dz square. Dz square is now if we talk about the dz square, its electron density is oriented along the z-axis. In addition to this z square has some spatial character, that is, so this is your z-axis, so the electron density is located along the z-axis. Now ये इसकी xy axis होती है y, this is x and y. X and y में इसका there is some electron density, some ring type of density in the form of a ring. It's also called as a collar tire. It's also called as a duff nut shape, this whole orbital. Some electron density in the x and y axis in the form of a ring, even though that is negligible, very less. But it's actually lobes are oriented along x and y. This is z axis. That's why it's called dz square. But in addition to that, some electron density in the form of ring is located along the x and y axis. It's perpendicular to the z axis, and so this is the shape of the dz square orbital. So this is the shape of the dz square orbital. So this is all about x, dxy, dyz, and dzx orbital, dxy, dyz, and dzx orbital, and then dx square minus y square. This set is also called as EG set in the symmetry and grip theory, and so this is called as a T2G set, this, and this. So this is all about the concept of the shape of the orbitals and the nodes and anti-node. This is nodes and nodal planes, or radial nodes and angular nodes. So this is all about the concept of the shape of orbitals at this BSc level. And then, so we have finished major part of the quantum chemistry, and again, if you have any question, please write down the question, and then I will try to make that question in the form of a video, a short video, that will be helpful to you people. Now इसमें ज़्यादा question बचे नहीं, बस 2-3 topics में बचे हैं, तो hopefully within 2-3 lectures or probably 4 lectures we'll cover the chapter number 1, that is the atomic structure. So this is all for the day.